Hello, I am going to work through a solution for the Module 8 DQ, and I just want you to know that this is one possible solution. There's actually multiple solutions, pretty much infinite number of solutions that can be made, and this is just one solution, one approach. So you're asked to start by choosing which data table you'd like to use. So I decided that I would use this data table here, the mean average temperature normal. If you chose a different table, your answer will be a little bit different. Or if you approached it a little bit differently, your answer is going to be a little bit different. That's okay. Part of this problem is to identify what assumptions we're making and to move forward with those assumptions. So I'm starting with this data table here. And the first thing we're asked to do is create a table. It looks like we already have a table, but the problem is our input is in terms of words instead of numbers. And so we need to translate this into a data table that we can work with numerically. So the first thing I did was I created a couple variables. I said that my input is the number of months since December, and I called that M, and that my output is the mean average temp normal in degrees Fahrenheit, and I called that T. Since the input is the number of months since December, that means January would be month 1. So I went back and looked at my table, and in January, I see that the mean average temp normal was 56.8 degrees Fahrenheit, and so I translated that data into this table over here. And I just went through the rest of the table and did the same. So the next thing we're asked to do is we're asked to identify the midline. Well, in order to identify the midline, the first thing that I need to know is what is my maximum and what is my minimum value, because the midline is halfway between your maximum value and your minimum value. So I look at my data here, and also I want to point out as a reminder here that this is actual real data. If you were to plot this real data, you would see that you do not get a sine function or a cosine function. Instead, you get something that looks kind of like it could be modeled by a sine or a cosine function. It looks similar. And so you could enter this all into Desmos and come up with an equation using regression that would give us the best fit model. But we specifically wanted to look at picking out data points visually and then making our formula from that rather than using regression. And will our model be exact? No, it is just a model. It models the real data. It is not the real data. So that being said, let me go look at the maximum value. I see that the maximum value is here in the 7th month, and it is 95.5 degrees Fahrenheit. I also see that when I look at my minimum value here, or look through this list of temperatures, and the minimum that I see, the lowest I see is 55.8. And so my min value is 55.8 degrees Fahrenheit. So in order to find the midline, I simply add these together, divide by 2 so that I can find the average. That's right in the middle. And I end up with my midline equal to y equals 75.65. A midline is a line, and so it needs to be identified as a line. And so we have to give the equation for that line, y equals 75.65. So this is telling us that according to the model, the mean average temperature normal for Phoenix shows an average of 75.65 degrees Fahrenheit. That's the meaning of that value. The next thing we're asked to find is the amplitude. So this is the midline. Next, we have to find the amplitude. Well, the amplitude is the distance between the midline and the peak, either the maximum peak or the minimum peak, so the distance between them. So to find the amplitude, I started with the maximum and subtracted from that the midline. The distance between those two values is 19.85. And this is the amplitude. And the meaning of the amplitude is this is the distance between the midline and the maximum value or the minimum value. And it means that according to the model, the mean average temperature normal for Phoenix varies by 19.85 degrees Fahrenheit above and below 75.65 degrees Fahrenheit. And that's just a value. It's not a line, it's just a number. 19.85. That's the distance between the midline and the peak value. All right, the next thing we're asked to look at is the period. And like I said, this is real data, so there is no real repeating exactly going on here. But I can see that I'm looking at 1 year's worth of data. And so that's 12 months. And so my period is 12 months. We're going to make a model that repeats every 12 months. So every 12 months, the temperature cycle is repeated. Also, this means that each month represents 1/12 of the complete cycle. Now, I want to go back and talk about something here that we looked at before. You remember before we chose this value as our maximum and this value is our minimum. We have a 12-month period. In a sine or cosine function, the interval between the maximum and the minimum value is always exactly half the period. So if our period is 12 months, we would expect for an actual sine or cosine function for the difference, the interval between the max and the min to be exactly half of the period. And you notice here, the real life data isn't like that. The real life data has only 5 months between here, not 6. And I'm okay with that. I'm going to say no problem. I could go back and choose different data. I could say, okay, the halfway mark is at month 1, so I could use this 56.8 as my minimum. But I'm going to just make the assumption that 95.5 is my maximum, 55.8 is my minimum, and I'm going to move forward with that to create my model, knowing that my model, like I said before, will not be 100% exact matching the data. Okay, so the next thing it asks for in the DQ is the graph, but I'm choosing to write the function first because what I really want the graph to be of is the model, not the actual data itself. And so what I'm going to do is write the function now, given the fact that I know the midline, I know the amplitude, and I know the period. So I can go ahead and write the function. And the function is going to be t is equal to a function of m. And you could just say t equals, or you could say f of m equals. I'm just putting them both there so that you can see that. T is equal to, is a function of m, and that is equal to 19.85 cosine. Oh, but why am I using cosine? Let's talk about that for a minute. The reason that I chose to use the cosine function is because right here, I know the maximum value and I know where that maximum value occurs. And the parent function for a cosine, right? If you think about your parent function, the parent function for a cosine function looks like this, where I'm starting at the maximum on the vertical axis and going down. So now I'm saying, okay, well, I have to transform that parent function, knowing what my amplitude is, knowing what my period is, knowing what my midline is. And so I start off by, okay, the amplitude is this, let's just write this, y equals A sine B x minus C plus D, right? The amplitude is the A. So 19.85 cosine. And what is my B? I know that B is equal to 2 pi over the period. And so cosine of 2 pi over 12. You can simplify that if you want. You could just leave it 2 pi over 12. X, my input here is M. So M minus, and the C value is how far I have to shift. I'm shifting 7 units to the right. So M minus 7. And then plus the midline, which is 75.65. And you can check this really quickly. You can say, okay, if M was 7, then I would say M minus 7 is 0. So cosine of 0 is 1. And then 1 times 19.85 is 19.85 plus 75.65 gives me my max value of 95.5. So I know I'm in the right path there. Okay, so now I have my formula, and this is what I'm going to graph. So let me show you what the graph looks like. So here is the graph. Like I said, I've created the formula here, and that is what I'm graphing. And so I've labeled my axes, M and T, very clearly. And then I put in my, my tick marks, counting across here. Let me get back to that pen. I've lost the pen. So yes, so here I've got the 1, 2, 3, 4, 5, 6, 7, and my peak is at, when the input is 7, my peak is 95.5. That's my maximum value. Then my lowest value occurs in month 1, right there. Minimum is month 1, 55.8, which again is not matching exactly what the table shows, but it is matching my formula and the assumptions that I've made. Then to get 2 full cycles, I have a period of 12 here, you can see. So from 1 to 13 is 12, 13 to 25 is 12. That's where all my minimum values are. And then my maximum is at 7, so my next maximum would be at 19 over here. I have a midline of 75.65. The midline goes across, and I get the y value of y equals 75.65. That's in labeling, sorry, that's labeling my midline. And I want to point out here that now this is a cosine function. It's sinusoidal, so it has the shape such that the function is increasing at an increasing rate, increasing at a decreasing rate. Then it is decreasing at a decreasing rate and decreasing at an increasing rate in the same manner over and over again. And the place where the function changes from being increasing at an increasing rate to increasing at a decreasing rate, you see that's always right here in the midline. So the concavity of the shape, the concavity of the function changes. Here I am concave down, concave up, concave down, concave up here, right? That concavity always changes as the function crosses the midline. So when you're drawing your graph, you want to think about how the graph is changing, right, as the input changes, and the shape of the curve is important. Now, again, I'm just going to say it one more time. Notice this graph does not line up with the data in the table, but it does match the function exactly. Okay, the next step is to solve. It says when does the temperature first drop below 80? So that's essentially saying, when is the output equal to 80? So here I have this worked out. So the first thing I needed to do was rewrite my formula here. T is equal to this equation, and then set my output equal to 80. So I have 80 equals all of this. I do a little manipulation, subtract the 75 off from both sides, and I end up with the 4.35 equals this part here. Remember, I'm trying to get m by itself, so I'm doing what I can, undoing according to order of operations, working backwards. So the next thing I do is divide by 19.85. This is one full term here, and I'm multiplying that term by 19.85. So I divide both sides by 19.85, and I end up with 0.2191 is equal to the cosine of some value, the cosine of some value. This is all part of my input into my cosine function. So what I need to do, right, is I need to figure out what that input is equal to. What angle gives me, when I take the cosine of that angle, gives me an output of 0.2191. And the way I find that is by taking the inverse cosine. So inverse cosine of 0.2191 is equal to that quantity, 2 pi over 12 times m minus 7. So I type that into my calculator here, right? I usually go to this, type cosine, and go back over here, parenthesis, 0.2191, and oh, wow, I'm not getting the value that I thought I would get. Let me make sure that I am in radian mode. So let's come here to my gear. I am in radian mode. Oh, you know what? I put cosine here. Oops, I'm actually looking for the inverse cosine. So let me go back over here and put in this -1 because I'm looking for the inverse cosine of 0.2191, not the cosine of that value. And there I found that. My inverse cosine is 1.3499. So that tells me that this angle right here is 1.3499 radians. But now you have to stop and remind yourself that there's always two angles that result in the same value of cosine. There's this angle here with its terminating ray ending right there. And then because of circle symmetry, there's this larger angle. Let me see if I can change the color on that. Let's go with green. The angle that starts here and goes all the way around to there ends here with this terminating ray intersecting the circle there. We can see that both of those endpoints would have the same cosine value of 0.2191. So even though the calculator can only give you this first result, there is a second result that you have to find yourself. And the way that you find that is, since we're working with trying to find this angle right here, this angle right here is not fully all the way around the circle. All the way around the circle would be 2 pi, but instead it stops 1.3499 radians before it reaches the end of the circle, which tells me that this, oops, sorry about that, tells me that that green angle there, let's call it theta, has a value of 4.9333. So that means that 1.3499 equals that angle that's inside there, right? The angle that's the input to the cosine function. But also 4.933 would be equal to that. So over here, like I have it written over here, I know that 1.3499 is equal to 2 pi over 12 times m minus 7, and also 4.9333 is equal to 2 pi over 12 times m minus 7. That's is the input into my cosine function, and either one of these values, actually both of them, result in the same cosine value. So now I have to solve for m in both cases, and when I do that, I find out that m is equal to 9.578, and m is equal to 16.4219. My period was only 12, so I subtract out the 12 and I end up with m is equal to 4.4219. That's in my, months 1 to 12 interval. This is mid-September, month 9 is September, month 4 is April, so that is in mid-April. And the question actually says, when does the temperature first drop below 80? And if we look back at my graph, I would say, look, month 4 is right, 1, 2, 3, 4, right? I'm first going above 80 right here, right about here. And then again, 9, so 7, 8, 9, right here is when I'm first going to reach 80. But the difference is this, I'm reaching 80 for the first time, going from cold to hot. And then the first time I drop below 80 is going to be the second time in the year when I reach 80. And so that is the first time that the temperature drops below 80, is in that 9th month, about halfway through that 9th month, so about halfway through September. All right, now we can also check that over here. I can type, for example, f of x is equal to 19.85 times the cosine of, and I'm going to put my division sign, 2 pi over 12. And then I want to come out here, get another parenthesis, and x minus 7, and my parenthesis, and my parenthesis, and then do plus 75.65. Go ahead and see if I can find that on my graph. So let me set my window, and I'll say I want x to be between, let's say, 0 and 26. Oops. 0 and 26. And I want my output to be between maybe 45 and maybe 105, just so I can see the whole graph. Come back over here and look at that. And if I then say, when is y equal to 80, and I can see that that happens right here, 4.422, the output is 80, and 9.578, the output is 80. Very close to the numbers that I got right here. A little bit off just because of rounding. Okay, all right, well, I think that answers all the questions. Went through the whole problem. Again, I made a lot of assumptions working through here, and you might have made a little bit different assumptions. You might have chosen a different table to start with, but hopefully the video helped clear up the process.